The Romans obviously had this phrase, Memento Mori, remember you're going to die, almost as a call to arms to acknowledge the beauty and shortness of life. The question I want to ask you is, do we really want to live forever?
We all accept philosophically that we're going to die someday. What we don't want is to die tomorrow. We've evolved to want to live, and that is a problem. What we want as individuals is not necessarily what's good for society, let alone the earth. There's a disconnect there.
Venki, thank you so much for joining me on this podcast. And, really, we could talk for hours on the subject of longevity, anti-aging, death, and how to reverse it. But what I really wanted to get into was, there's an inescapable fact of nature that everything alive ages, and then everything that's alive also dies eventually. And that seems to be a basic concept, but there's some nuance behind that. And I guess the real question I want to ask you is, why do we die?
We die because evolution has not selected against death. So you mentioned everything dies, but of course, although we're all made of the same material, protein, DNA, RNA, lipids, species die at many different rates. For example, some insects only live a day. And then at the other extreme, there are even vertebrates like sharks and whales that live for several hundred years. In fact, I like to joke that there's a Galapagos tortoise, which could live for up to 200 years, that might still be walking around, but had encountered Darwin 150 plus years ago. So the question is, why is it that different species age and die, have such different lifespans? And that's because evolution doesn't select for longevity. It doesn't care how long you live. It selects for your ability to pass on your genes, for the likelihood that you're going to pass on your genes. And so it selects for what biologists call fitness. Let's give an example. If you're a mouse, there's no point in evolution selecting for a mouse that would live very, very long, because that mouse would be eaten or die of starvation or some other cause long before it gets old and dies. So in the case of the mouse, evolution has selected for a species that puts all its resources into rapid growth and maturation and producing lots of offspring. In the case of an elephant, the equation's different, and with the whale, it's different. So that, in a nutshell, is the evolutionary argument for why things die. It's because maintaining and repairing a body takes resources, takes energy and resources. So they'd only do that if it's advantageous for the survival of the species.
So when we say that something is dead, and certainly when we die, most of the cells in our bodies aren't actually dead. They're maybe aged or stuck in this sort of stasis and contributing towards that death process. So, which is why we can do organ transplants and give someone a new liver and they can function again.
Yeah, no, that's exactly right.
So what is the definition of death in that instance then?
Yeah, so death is a peculiar concept because the flip side of what you said is that cells in us are dying all the time. We don't even notice it. And in fact, often their death is actually required for the function of the organism as a whole. And so what we mean by death is the death of the whole organism, the individual, and in the case of the human, the individual human being. And that means our inability to function as a coherent whole person. That happens when a critical system fails, and then you have some inability for the entire organism to survive as a whole. And typically, if a critical system like your heart or your brain fails, then the rest of the body will eventually follow. And that's what we mean by death.
I mean, there was an interesting study done on reperfusion treatment on dead pigs, and this was also trialed on human brains. And this reperfusion treatment allowed certain parts of the human brain to, reanimate and show some evidence of function. And this got people excited, naturally, thinking that death could be a reversible process. I mean, how far are we to reversing death?
I think, you may be able to reverse some things temporarily. For example, 100 years ago, the the typical criterion for death was when your heart stopped. Now we don't use that criterion anymore because with CPR, we know that even after the heart has stopped, you can revive heartbeat and make the person, survive and be alive. And so now, in most countries, the legal definition of death is irreversible loss of brain function. So now, I guess what you're saying is, well, maybe by infusion you could delay loss of brain function or possibly reverse it. I think you may be able to do it temporarily, but I think it'd be very hard to reverse uh, that kind of process indefinitely, because usually the critical system failure is a symptom of an underlying aging process. Things have reached a point where they're no longer functioning well.
I mean, it seems that, throughout human history, the quest for immortality, the quest for extending our lifespan has almost taken on this mythical type quest, and it's almost the, bordering science fiction. And for many, many decades, this anti-aging longevity field has been seen, as like a backwater specialty. But over the last couple of decades, it's really come to the fore with a lot of investment into it. Now, what is the reason behind that? Is that because of our insatiable appetite to live forever in the midst of rising cancer rates and metabolic disease and chronic disease? Or is it because the science has finally caught up with the fantasies of science fiction?
Well, it's a mixture of things. The recent boom in the longevity field is due to a mixture of things. We've always wanted to live to defeat death. I mean, even the Chinese emperors, the pharaohs in Egypt, they all wanted to defeat death. But what's happened recently are two things. One is that molecular biology has made great strides in understanding some of the key causes of aging. And it's really aging that leads to the kind of death we're talking about. We're not talking about death by accident or some serious disease or calamity or something like that. We're talking about the natural process of old age and death. So that molecular biology is coming to grips with the various causes, and it's giving people some feeling that now that we understand many of these processes, maybe we can interfere with them and slow down aging and therefore at least live a healthier life. The more extreme view is that we might be able to extend life, but the majority view is at least it might give us a healthier life. The other reason for the big boom is that societies all over the world are aging. This is because people are living longer, and that's largely due to better health and better medicine. At the same time, fertility rates are dropping. And this means that the population on average is getting older, that it's being skewed more towards the older end. So that creates a real imperative to make sure that this aging population remains healthy and preferably independent and productive. That means trying to understand the causes of aging and seeing if we can do something about it. So governments are investing a lot in aging research. And of course, there's a huge interest from industry because people are aging, they naturally want to be healthier, they're susceptible to wanting to try all kinds of things, and there's money to be made. There are about 700 startups with many tens of billions of dollars invested in longevity research, and it ranges from what I would call quite mainstream, unobjectionable research to really some dubious practices and claims.
It's interesting that over the last few decades, we've not really seen that age barrier crossed. I mean, I think the oldest person recorded to have ever lived was 122 back in the 1970s. And, 50 years on, we haven't crossed that threshold. So going back to your earlier point saying that evolution selects for fitness, do you think there is an evolutionary barrier, a ceiling set for humans at the 115, 120 mark? And is there a reason why evolution wouldn't make it possible to live forever?
Both are true. I think the way evolution has acted on our species, it has selected for species that whose natural limit is about 110 or so. There are very, very few outliers who go past 110, and even fewer past 115, and only one past 120. And so that suggests that there is a natural limit to our species, and we have evolved so that all of our repair mechanisms and wear and maintenance mechanisms simply sort of give up at around that point. So that is true. But there's no physical or chemical law saying that if we were to interfere with the processes of aging themselves, which are the result of evolution in our case, so if we were to be able to interfere with that, then we might be able to extend it. So, but I think it'd be very, very hard. I think it'd be easier, I think, to improve health in our old age. I'm talking about, say, our 80s or 90s. That I think is more feasible than really pushing it beyond 120. I think that would require a number of things to work in concert. Although the more optimistic people claim, oh, it could happen any day now, but I'm more skeptical about it.
So I guess that refers to, quite a interesting point you made in your book, Why We Die, about the compression of morbidity, so that maybe, in the sort of pursuit of increasing our health span, we need to potentially focus less on the reversing biological aging and focus more on shrinking the number of life years we have where we're sort of besotted with chronic disease like hypertension, diabetes, and other cardiovascular insults and various other chronic diseases like that.
Yeah, and then an important one you didn't mention was dementia, which I think is going to be an increasingly prevalent disease in old age because it's the one that's hardest to tackle. So you raise a very important point, which is all of the conventional aging research community is talking about compression of morbidity. For example, the head scientist of Altos Labs, a big billion-dollar investment by tech billionaires in California, but there's a branch right here in Cambridge. He said, our goal is not to extend life, but our goal is for everybody to die young after a long time. Now, what he means is that you stay healthy and then suddenly you die. And that concept, where the period in which you have diseases and disabilities, where you need extensive care and you're, generally speaking, not a very happy person in terms of health, that period they want to compress, and that's called compression of morbidity. Now, there isn't really very good evidence that it's possible. For example, all of the advances that have extended health in the past, for example, by treating cancer, heart disease, diabetes, they've all increased our health, but they've also extended our lifespan. And so the result is that the period that we have with disabilities has not actually decreased. It's, in fact, if anything, it's increased, because as a fraction of our life, it's about the same. And so there is a danger that as we improve health in aging by interfering with the process of aging, you may simply be postponing this long, slow decline to a later time. So you may actually be extending your lifespan and having long period, maybe even a longer period of morbidity. That's not entirely clear. The one counterexample I would say is studies of supercentenarians, people who live to be 110 or so. Those people seem to have extraordinarily healthy lives and then go through a rapid decline and die. So in their case, at least, they've somehow managed that compression of morbidity. But I'm not sure how translatable that is to the general population, because when you look at these people who live over 110, they're very few. So we may be looking at some kind of survivor bias. These are simply the people who lucked out, either by their genes or some combination of lifestyle, life history. They've managed to dodge various bullets along the way and survived. So it's not clear that what they have is something that could be adopted for the rest of the population. But that's an active area of research, and people are looking into both their genetics and their life history to see if there's something that we could learn from it.
Yeah, I mean, I guess if we had a blueprint to look at for healthy aging and improving our lifespan, it would be these super centenarians and people who are regularly living beyond 100. And I guess my rebuttal to that would be, unfortunately, it seems that there's a lot of poor bureaucracy and data keeping, which potentially undermines some of that research. Because I think there was a scientist that I had on this podcast recently who won the Ig Nobel Prize for
Absolutely.
exposing the blue zones.
Yeah, it's a
A
great
lot
piece of
of
work.
fraud in that industry, and a lot of sort of pension fraud and tax fraud, and people basically lying about their birth and death dates. So I guess that sort of undermines our ability to look at these people and
Yeah,
actually take actionables from them.
that's true. I mean, there is, a lot of the blue zone effect goes away when you really restrict it to only those people with very good record keeping. But quite apart from that, there is this question that I raised, which is it's simply maybe survivor bias. You're looking at just the ones that happen to be lucky and survived, and there might not be general lessons for us. But I think that's something that only time will tell.
If you look at the process of aging, I guess it's wrong for us to think that there is one singular cause for aging. It's multifactorial. There's not just a single gene for aging. It's an accumulation of errors and insults and DNA mutations and inflammation over our lives. So is there anything in the current research and science going on right now that's sort of pointing us in the direction of reversing that aging on a cellular level?
There are several aspects to that. So it is true that there isn't a single cause of aging, but the causes are somewhat related. For example, one primary cause is damage to our genome. And that could be DNA damage or damage to the ends of our chromosomes which get shorter, or modification of our DNA, which changes the program of genes that are expressed as we age. So that then has a knock on effect. It affects the program of what proteins we make. And these proteins actually carry out all of the functions in the cell. And then that, of course, affects the cellular compartments, like these organelles in our cells called mitochondria, which are essentially where energy production is carried out and a lot of metabolism. It's a big metabolism hub in the cell. And then that affects, of course, our cells' ability to function and communicate with other cells, which affects our tissues and our immune system. So you can see they're all sort of related, even though you could think of them as having different levels of complexity, the molecules at the very basic level of complexity, then going into collections of molecules, then to organelles, then to cells, and then to tissues, and then the entire uh, animal or person. And so it is true it's multifactorial, but they're sort of connected. Okay, and they're connected in the sense that each level affects the level not just above it, but also even the ones below it. So it's not even a strict hierarchy.
If we look at some of the factors which potentially contribute to aging, so for example, for the average person listening right now, they may not know, but the ends of the DNA, we have these little caps called the telomeres, and the telomere shortening obviously contributes to that aging process. So if we try to stop the shortening of those telomeres, we could induce or increase the risk of cancer formation. Similarly, if we try to reprogram cells by making them kind of baby cells or stem cells again from their adult cells, we could reverse aging, but also increase the risk of cancer. So there seems to be this sort of mismatch between aging, or balancing act between aging and cancer. If we try to reverse aging, we might increase the risk of cancer. So
That's a very, very good and very general point. And you remember I mentioned about evolution not selecting for longevity, but it's actually more interesting than that. Evolution will often select for traits that are advantageous when you're young. For example, growth. So, growth hormone pathway helps you grow and mature and things like that. But that very same pathway causes problems with aging later in life. And the interplay between cancer and aging is something that we see time and again. You mentioned about the shortening of telomeres. Well, what happens is when the telomeres, which are the ends of our chromosomes, which contain our DNA, when they become short, they unravel. Then the cell thinks of it as a break in the DNA, thinks of it as damaged DNA. And so it sends the cell into a state called senescence, where it can't function normally and it secretes inflammatory chemicals so the immune system can come and clear it away and repair the damage. Now, you can see why that evolved, because early in life, a cell with breaks in the DNA is a cancer risk. And so it evolved a DNA damage response, which senses the DNA damage and gets that cell out of harm's way, doesn't let it survive and reproduce. Uh, but that same process later in life causes us to age because many cells start suffering various kinds of stress and damage and go into senescence. And so we have an overpopulation of senescent cells and just systemic inflammation, which actually almost feeds back and creates, and you get this feedback loop where you get more and more senescent cells being formed. And so, again, you have this interplay between something that prevented cancer early in life becomes a problem later in life.
I mean, over the years, when I've been working in the hospital, and particularly when I've been operating on patients as well, I've learned to almost ignore the discrete chronological age that people have been given, because I can see two 60-year-old men who will be completely different in their physiology. The only common denominator will be their age, which is 60, and maybe their ethnicity. And one can be really fit with a good baseline, walking miles and miles a day, and the other will have multiple comorbidities and maybe get short of breath climbing a flight of stairs. And I guess the sort of the link between the two would be, how can you have two people who are essentially the same age but so different, I guess, in their phenotype in their life. And it comes to this point of DNA methylation, this accumulation of these chemical tags on their DNA. Maybe the person who isn't so fit has lots of this methylation tags, which is resulting in them being more physiologically more geriatric or age compared to the fit 60-year-old. So I guess if we're using DNA methylation as a marker of aging on a microscopic level, is there any way to remove that tag and make someone healthier or de-age someone based on that?
There is a lot of work in this area. So the one thing we do know is that the methylation patterns are laid down as we age, and they're laid down at different rates in different people. But interestingly, they're even laid down at different rates in different tissues in the same individual. So it's almost incorrect to talk about someone's biological age as a single number, because you may have an older liver, but your kidney might not be quite as old, for example. But that's shown to be true, that the methylation pattern is almost a better predictor of how likely it is you're going to die in the next coming years compared to chronological age. It's a better predictor of what they call mortality. And so people say it's a better marker for the so-called biological age. Although, as I said, it's biological age. I don't agree that it's a single number. Anyway, that's true. What isn't so clear is if they reverse the methylation marks, that they're going to suddenly also reverse your age. That there are people who claim they've done experiments along those lines, but that's more controversial. Because what we don't know about this methylation is it causation? Is it the methylation that's causing the aging? Or is it simply correlated with aging? That as you age, if you age faster, you lay down these methylation marks more.
So do you think actually when we're moving towards an era of personalized or hyper-personalized healthcare and treatment for people, we should move away from biological aging as a discrete number and actually look to age-specific organs so we can actually target treatment and make bespoke treatment for individual patients?
Yeah, I would be more enthusiastic if there were actually treatments that would improve a particular organ. We're not. I don't think we're there or anywhere near there yet. And I personally am somewhat skeptical there are lots and lots of companies now that have sprung up that will sell you a kit to determine your so-called biological age for a few £100 a
Hmm.
pop, and that's great. They'll take your sample and they will analyze either your DNA methylation, or there's another way, which is to look at your blood enzymes, or how much sugar has been added to your proteins. That also changes with age. Each of them will claim that their marker is better. Some of them will sell you a combination of markers. And the question is, what will you do with that number? And currently, there's not much you can do that you shouldn't be doing anyway. I mean, you should be exercising and doing all the things that keep you healthy, regardless of what this number from some kit tells you. So I'm fairly skeptical about these efforts. But as I say, there are a lot of there's a lot of capitalizing on people's fears of growing old, and we are reaching a stage where the boomer generation that's used to, and I'm one of them, so I can be critical. The boomer generation has been used to having its way all its life. Things worked out very well. They've ridden the wave, and now they're getting older and they don't like it. And so that's also driving a lot of this market.
So, Venki, if these at home tests work to analyze someone's biological age, what metrics can they use in their daily life to then say, I've actually improved my biological age? For example, my VO2 max is better, my blood pressure is better, my HbA1c is better. Are there any markers that someone could say that they've improved their biological age with?
Oh, I think all of those things that you mentioned are worth looking at. For example, let's say they have biological markers like methylation or glycosylation, which is adding sugars to your proteins. There's a rate at which that happens. And let's say they take measures to be healthier. Then, if that rate goes down, it means they've somehow slowed down possibly the process of aging. But apart from that, there's things like VO2 max. Another thing that's highly correlated with healthy aging is grip strength and your ability to walk distances in a short amount of time. So there are a number of uh, markers for fitness, and as well as biochemical markers. And you could assess that and see if your interventions are actually either keeping you healthy or at least slowing down your aging process. I'm not sure how personalized this is, because I think that these measures are not going to be based on your particular genome and your particular result. I think the measures are going to be very general, because anything that improves healthy aging is going to do it for almost everybody. So I'm a little skeptical about the whole personalized aspect of it, but I realize there's a lot of money in the business.
Yeah. I mean, you mentioned before that there's differences in the lifespans of various animals. You can have sharks and whales and elephants who live, a number of years of magnitude more than humans. And then you've got rabbits, rats, mice, flies who are living, significantly shorter lives than humans. What is it about these different creatures that we can maybe learn from and then apply to human science to reverse aging to some degree? Because, for example, a common question that people ask in pop science is, why don't elephants get cancer? Despite them having so many more cells than, humans, they get cancer in a very astonishingly small frequency. So is there things that we can apply from these animals, from nature, and translate that into human research that we're doing?
It it'll be hard, and I think part of the reason is that species have evolved a complex balance in their metabolism, in their physiology, that is a balance between repair and maintenance, and growth and maturation, and various other things. And that's what determines lifespan, as I mentioned. So you mentioned the case of elephants. It's a paradox known as Peto's paradox, after the person who first formulated it, which is the idea is if you have lots of cells, if you have many more cells, the odds that one of them becomes cancerous is much higher. So that animal should be more prone to cancer. And in the case of elephants, it turns out they have 20 copies of a DNA repair protein, whereas mice and we only have two. And so they clearly are better in some ways at DNA repair. And so they're preventing cancer from developing early in their species. And if you look similarly at very long lived whales, it turns out they have all sorts of DNA repair mechanisms that are not the same as ours, and certainly not the same as in mice. So you can see how in those species, nature has chosen to put more effort, more resources into repair and maintenance. Now, the question you asked is, can we learn from that? Well, we can learn biology from it, but I don't quite know, and I don't think anybody does, how to translate that to something beneficial to humans. I mean, what are we going to do? Create transgenic humans where we've cloned in multiple copies of DNA repair genes? We don't even know what that'll do to our physiology. So I think it's quite complex and not so. I think we'll learn a lot, and from the general understanding of the biology, we'll be able to then apply it in a broad but indirect way to our own biology. But I'm not sure we can directly take information from some other species and say, oh, this species does it this way, so let's
Mm.
engineer that into humans. That's, I think, asking for quite a lot.
I think something you said there was really interesting because the unknowns and what the knock-on effects of certain things are. And I see this anti-aging longevity space as a spectrum. You've got obviously on one end the sort of sane end of research, and you've got mainstream research, and then you've got I like to refer to them as the geronauts. These kind of longevity astronauts trying to really push the boundaries and take that leap.
Yeah.
Sometimes doing N=1 science, which if they want to fall off the cliff first so other people can learn lessons, so be it. And there's a lot of people who self-medicate with these things to biohack their biology in some way. And I guess
including, I should say, many many respected scientists who work in longevity are quietly taking all kinds of things on the side.
I guess the question then comes back to the point you raised. Whilst there may be some mechanistic understanding of some novel medication providing some degree of benefit on a cellular level, so for example, maybe metformin or rapamycin seems to be the trending substance these days, I guess we don't have any idea of the sort of knock-on or off-site or unintended effects of that thing, because these are all very complex metabolic and biological pathways. So whilst it may show on the surface, hey, this can reverse aging from a cellular level or at least decrease senescence and cellular aging, we don't know what it does 20 streams that way in terms of your biology and completely screwing your body.
No, that's an excellent point. And you raised two very interesting chemicals, so metformin and rapamycin. Now, both of those are in some ways related to the general idea of caloric restriction, which I think is certainly something that seems to work. And this is the idea that if you restrict the number of calories in your diet, then it improves your health in old age. And people have shown that in many different species, from flies and worms to mice, and not in humans, but in chimpanzees as well, or monkeys anyway. The idea is that, of course, what they're doing is they're comparing animals that are fed an all-you-can-eat diet, very rich all-you-can-eat diet, with an animal that has just sufficient number of calories to live, but not to starve. So it's not losing weight and starving. So when they do that, they find the calorically restricted animals tend to resemble younger animals, and they seem to be healthier. Now, some people have argued all it's saying is that an all-you-can-eat rich diet is very bad for you. And that's true. So they haven't done quite the proper comparison. But nevertheless, if you don't overeat and eat a modest number of calories, that seems to be beneficial. And they've shown that caloric restriction affects certain pathways. We don't know all of the pathways probably, but at least two of the pathways involve these drugs, metformin and rapamycin. Now, metformin is interesting because it's a widely approved drug for diabetes. So there are millions of people already taking metformin. But the question of whether it benefits healthy people is controversial. There was some indication that it did originally, but then other studies showed that it didn't. And so there are some large scale trials which are underway to ask what is the effect of metformin on healthy people. And although the trials have been going on, or maybe at least were proposed for quite some time, I haven't seen any results emerging yet that are definitive. Now, rapamycin is an interesting thing because it's a drug approved for organ transplant recipients to prevent rejection of their transplant. And the reason is it's an immunosuppressant. That's great if you're an organ transplant recipient. You want to live and not reject your organ. And so, of course, you have to take it. But to ask healthy people to take an immunosuppressant over a long period when it'll make you not only more prone to infections but also have all kinds of other side effects, that's a tall order. And yet, on the basis of studies in mice that show that rapamycin mimics some of the effects of caloric restriction, there are people who in this field who are quietly popping rapamycin on the side. And I guess that just shows that scientists are like everybody else. They're not completely rational when it comes to their own lives, because rationally, the thing to do would be to wait for proper long-term trials in humans. Now, what they would argue is that you could adjust the dose, that you could give rapamycin in lower doses so it doesn't have the bad side effects of immunosuppression, et cetera, but maybe still has the beneficial effects. But I'm not sure that's possible because maybe the two are related. The very fact that it's immunosuppressive is related to why it's having its effect on aging. There's an interesting trial that's been proposed for rapamycin. See, that normally people do this in laboratory animals like rats or mice, which are kept in sterile cages and they're genetically uniform and so on. So it's not a real life environment. So they thought, well, we should maybe give it to dogs, domestic dogs. Dogs have a much shorter lifespan than we do, and medium-sized dogs or large dogs tend to have a shorter lifespan. And so they thought they'd do it to medium and large-sized dogs. And the idea is that dogs are not in a sterile environment. In fact, they're in a whole variety of environments that mimic humans because they're as varied as their owners. And so that would be a great trial, I think. And then you could see, do these dogs get infections? Do they have other problems? Or do they actually live a longer and happier life?
I guess to your point about a lot of these scientists in industry quietly popping rapamycin and novel medication which may or may not provide any benefit to them at all, I guess there is something to be said about the sort of very idiosyncratic scientists actually providing the first breakthroughs. Like I can think back to Dr. Barry Marshall, a gastroenterologist who also won the Nobel Prize like yourself, who, swallowed H. pylori bacteria and proved that was the cause of stomach ulcers, and then, led to the sort of treatment of H. pylori. So I guess some of this testing that we have, we sometimes need these slightly crazy, kooky people to really push the barriers. Because
I agree with some of that, but I will push back a little in that by the time Barry Marshall swallowed H. pylori and then treated himself with antibiotics, he had very, very strong evidence from animals that was actually the cause of ulcers. And so he really, I think, wasn't taking as much of a leap. The problem with anti-aging medicine is the following. If you have a serious disease, even ulcers, but let's say you have serious disease like cancer or diabetes or high arterial obstruction or things like that, then and especially cancer, if it's a life or death situation, you'll be willing to take all kinds of nasty chemicals to eliminate the cancer because the alternative is you're going to die. Okay. But if you're asking, should I take this medication for the next 10 or 20 years in the hope that at the end it'll give me another 10 years of healthy life? That's a completely different balance of risk and benefit. So I think anti-aging therapeutics has a problem. It has a
Mm.
higher bar to overcome before it's sort of generally acceptable for long-term treatment. Now we do take long-term treatments which are almost anti-aging in some respect. For example, I take a statin and I take blood pressure medicines, and both of those are really about keeping me healthier as I age. But the fact is, those have been tested
Yeah.
in millions of patients or extensive clinical trials before they were approved in the marketplace. So it's rational to take them, and that's what's needed for anti-aging medicine.
Yeah, absolutely. And I guess, on top of that, some of the drugs you mentioned, blood pressure medication, statins for cholesterol, they have become so widely tested and they have been proven to work for over such a long period of time that the cost is accessible usually to the average person, not just the preserve of the ultra rich or the tech billionaires. And unfortunately, the anti-aging space is dogged by the fact that a lot of these novel therapies, some that do work, some that don't, all of them are relegated to that ultra 0.1% of society that can afford these things. So I guess one of my fears would be, as we progress in our science of longevity and we do come up with more therapies that may prove beneficial, whether it's to treat chronic disease or even for longevity and reverse aging to some degree, that will continue to widen the health inequalities and disparities between, in society that we have, where you maybe have the ultra rich living a decade, maybe 2 decades longer than, people in a lower socioeconomic status. And that's quite worrying.
Yeah, it is a very serious point, and it's something I've talked about fairly extensively. It turns out that even today, even in the UK, which has a national health service and therefore healthcare accessible to all, the richest 10% live about 10 years longer than the poorest 10%. And in the US, it's about 15 years. But it's worse than that. It turns out that the health span, the number of healthy years, is almost double. The difference is almost double. So the difference between the healthy life of a poor person, healthy life of a rich person is 20 years and not just 10 years. And in the US, it may be even more. So the question is, if we now have specific anti-aging medicine, will it increase this disparity? And it very well could, depending on the nature of the therapy. So if you have very sophisticated stem cell therapy, for example, that might only be accessible to very rich people unless they have insurance or unless the NHS pays for it and so on. And by and large, I would expect rich people to be the first to take advantage of that. On the other hand, if you have something that's a very inexpensive pill, let's say something like a rapamycin analog or metformin analog, or maybe chemicals that might attack senescent cells, and they can be cheaply produced and they can eventually become as widespread as statins or blood pressure medicines, then of course that's a benefit that perhaps everybody could avail themselves of.
I guess another ethical conundrum of anti aging research and the consequence of that, if we have a large volume of people living longer, as you see in Japan, for example, and we've seen the social and economic consequences of that, how do we plan for that now?
It's going to be hard because, as I said, it's not even just that people are living longer, but they're also fertility rates are also going down, and they're going down for a variety of reasons. At least, I think the major reason sociological. Women are now empowered, and it's quite understandable that they don't want to sacrifice their career and so on by having several children. And so even in places like India, India is now almost at replacement rate, and many states in India are below replacement rate. And so what you are going to have is more and more older people, And if now they start living even longer, then you have a situation where you have, first of all, a smaller fraction of younger people in the workforce that will have to support an increasing population of older people. But even if you figure out ways to keep older people healthy and productive, there is this problem that you then have a society which has very low turnover. And so as people age, they tend to typically accumulate wealth, power, influence, and so on. And so what you'll have is a society, I think, that'll have less turnover of ideas, of power, in general, a less vibrant society and less creative society. I think people also forget that in many fields, people are more creative when they're young than when they're
Mm,
old. And this has to do with a number of things, not just cognitive decline, which is, of course, a real fact, but also the fact that when we're young, we are seeing things fresh for the first time, and we've accumulated less bias over a long lifetime. So we're more open-minded, and that leads to creativity. So I think it will create a different kind of society, and something that we don't talk about and we're not really prepared for.
Now, I wonder, with all the billions being poured into anti-aging research, are we leaving simple, low-hanging fruits on the table? For example, on the topic of India, air pollution is, abysmal in India, and we're leaving life
Horrible.
years
I
on the
just spent
table.
a few weeks there,
Yeah,
and
well,
and
I hope you masked up.
we did mask up sometimes, but it's so also
It's
uncomfortable because it's
difficult,
fairly
yeah.
warm and sometimes humid. And I do have to say, what I noticed was that the well-off in India, and this again has to do with this health disparity you just mentioned. The well-off in India have essentially seceded from India. They live in
Yeah,
their air-conditioned homes with air purifiers. They go in their air-conditioned cars to visit their friends or their offices
yeah.
or clubs. And the 95% of the people who can't afford this have to face the consequences of all this horrible uh, air pollution and so on. And yes, I think that is, certainly if I were a public health official in India, I would put far more money in improving air quality and public health and sanitation, clean
Yeah.
water and public toilets and so on. I would put far more money into those than I would put into anti-aging and longevity research. That's much more pressing. But and of course, infectious disease, which we didn't touch on. But I think in well-off countries, it's not often an either-or situation because people do want to tackle existing diseases and public health and so on, but they also do have this growing population of older people, and they want to ensure health in old age. So that has become an imperative.
The Romans obviously had this phrase, memento mori, remember you're going to die, almost as a call to arms to acknowledge the beauty and shortness of life. So you can make more of the limited time you have, in life. And I guess the question I want to ask you is, do we really want to live forever? And if someone were to live to 200, would that in some way blunt their drive to be creative, to be innovative, to kind of seek new heights because they know I've got 200 years to live rather than 80?
I agree with that. I'm not sure everybody does. Certainly, many of these longevity advocates would disagree with me. For example, what they would say to me is that, look, 100 years ago or 150 years ago, on average, life expectancy was about half of what it is today. And so, would you want to go back to that time? And if we increased it by a factor of two, what's wrong with increasing it by another factor of two? Well, there are a couple of things wrong with that. Those early advances were about reducing infant mortality and untimely death. They didn't actually extend the limits of our biological lifespan, because even in olden times, people like Michelangelo lived to be almost 90. I think he died at the age of 89. So it's not that nobody lived for a very long time in olden times. It's just more people were dying of disease and avoidable scenarios. And what we're trying to do now is tackle things which are essentially inevitable and trying to avoid those. So there is a fundamental difference. The other is, you asked whether would we want to live that long, and that's goes back to an old joke, which is, you ask somebody who would want to live to be 100, and the answer is somebody who's 99. And the problem is, we all accept philosophically that we're going to die someday, memento mori, as you said. But what we don't want is to die tomorrow or the next week or the next year or even the next decade. And so if somebody were to come to you and say, here's a pill that'll give you an extra 10 years of healthy life, very few of us would not take it. In fact, the reason I'm taking statin and blood pressure medicines is precisely because I want to stay healthy for longer. And so I think human nature, we've evolved to want to live, and that is a problem. What's good for what we want as individuals is not necessarily what's good for society, or let alone the earth. There's a disconnect there. And I don't know. I mean, I don't think that's a easily solvable problem. The other issue, of course, is if we live to be 200, we'd be wondering about why aren't we living to 400? So I think
Yeah.
it's a sort of never-ending
Yeah.
goal. This immortality. It's almost a meaningless quest. And then the final thing you asked about drive, I do think our mortality is what gives us drive. There's an old saying, I think one of Parkinson's laws, that work expands to fill available time.
Yeah.
If somebody gives you 6 months to do something, you'll take 6 months. And if they say you have to do it in 6 weeks, you'll do it in 6 weeks. And so if you have a very long time, there will be the tendency, oh, I can do it tomorrow. I've got lots of time. But our finite life gives us some urgency. And you can see that in the creativity and output of writers, musicians, scientists. You look at the old scientists, Gauss or Newton, they were no less productive than modern scientists, even though they lived on average shorter lives. And, all those great musicians who died in their 30s and 40s and 50s, even Beethoven, he died in his 50s, which would be considered young today. So I don't see that modern composers are doing more with their longer lives than people like Beethoven or Mozart. So I do think that you do get a sense of urgency and drive
Mm.
from having a finite life.
I mean, I look at people like Brian Johnson, who's obviously, made it to the forefront or is the poster child of the anti-aging movement. And whilst I admire and commend his diligence for N=1 science and, pushing the packet out there to see what works and what doesn't, obviously he's got the financial resources to do such things. From an external point of view, looking at what he does in his supplements and regimes, it seems very stressful to adhere to such a strict protocol where you can't,
Absolutely.
err away from the, discrete number of calories to consume, these supplements, the testing.
Yeah.
So I guess, the stress in life is also, an aging accelerant.
Oh, I think, I was slightly down on Brian Johnson until I watched some of his videos.
Yeah.
And to me, he seems like a very nice guy and enthusiastic about what he's doing. But I think he's got this weird obsession about aging and death, which is preventing him, I think, from actually making the most of life because he's
Mm.
spending all his time or a good fraction of his life on longevity extension, longevity treatments, and measuring various parameters about himself when he
Yeah.
should be out
Yeah. To what
really
end? Yeah.
creating and enjoying life and doing what he finds enjoyable. Well, maybe he finds this enjoyable, but I find it rather strange.
I think, ultimately at the end of this conversation, we've spoken about this kind of fantastic research that's being done in longevity. But I think the boring, unsexy truth is that sleep, diet, movement, less stress, all those things are the boring, routine things that will still extend your lifespan and health span as well, probably.
Yeah, the thing I like to say is that the research has not been in vain. For example, we now, although these kinds of measures like diet, exercise, and sleep, they've been advocated. Our grandmothers would probably have told us that. But what we do know now is exactly why they work. For example, what is it that sleep does, and what is it that exercise does to our biochemistry and our physiology that causes its beneficial effects. And same thing with moderate diet, which has to do with these caloric restriction pathways. So we understand much better why they work, and that gives us confidence that actually these things are really worth doing because they work and they have knock-on effects. For example, stress is a driver of aging. But of course, if you exercise well, you sleep better, and the combination then also reduces your stress. And the same thing with and helps you improve your diet. So these things are all synergistic. And to the things you mentioned, I would add very inexpensive things like getting a test for high blood pressure, for diabetes, for cholesterol, because these are easily detectable and very cheaply and efficiently treatable. And they too will improve health in old age. And there are a couple of sociological things that I ought to mention. And that is, it's shown that people who tend to have good social networks and don't isolate themselves in old
Mm.
age tend to live longer. Now, again, this could be correlation rather than causation, but there is a feeling that isolation is bad for you. It increases mortality, maybe it increases depression and stress for whatever reason. And the other is that, oddly enough, people with a sense of purpose tend to have lower mortality. And this is an argument that when you're older, maybe you should become involved in projects, perhaps in community projects, in altruism, in volunteer work. So all these things can help. And these are not things that cost a lot. Although I will point out, all of these things are harder for poor people to do. For example, we talk about health, diet, and exercise as if it was free. Sleep, diet, and exercise. A poor person will have to grab whatever food they can find on the go. They may be working multiple jobs or long hours, so they won't have time to exercise. Their sleep pattern may be not as good. So all these things that we who are well off can take for granted is also harder for poor people. And that's part of the reason you also have health disparities.
Really fascinating discussion because there's obviously lots of interest in the longevity space, but there's also a lot of skepticism that's needed. And hopefully, people listening to this can go forth into this anti-aging world with a healthy dose of skepticism. So, thank you very much, Venki.
Thank you. And I should add, there is a lot of really good research, and I am hopeful that in the end, we will get really good therapy that will at least keep us healthier for longer. But in the meantime, there are things we certainly can do ourselves. Thank you.
Thank you.